Differentiation.
Assalamualaikum, my name is Afif Khadijah Binti Hairul and my ID is 2024689684.
Hello, Assalamualaikum. My name is Muhammad Farish Haikal bin Hassan and my student ID number is 2024283646.
My name is Nurhasha Christina Binti Razak Kamhiza. My student ID is 2024406884.
Assalamualaikum. My name is Musliha binti Muhammad Nizat. My student ID is 2024215346.
So I would like to explain about the differentiation. What is differentiation? Differentiation measures how a function changes as its input changes. If y depends on x, the derivative dy dx tells us the rate of change of y with respect to x. You can think of it as a slope of the graph at each point. In many problems, we use derivative to find speed, growth, maxima and minima, and how one quantity reacts when another changes. 5 rules include the constant, power rule, product rule, chain rule, and lastly is quotient rule. One is the constant rule. The constant rule states that the derivative of any constant number is always 0. This is because the derivative measures the rate of change, and since constant by definition never change, their rate of change is non-existent. For the example, for d per dx, c equals to 0. For the second is power rule. The power rule is the foundational calculus shortcut that lets you quickly find the derivative, the rate of change of or slope of the variable raised to a constant exponent without using tedious limit definitions. The rule states that to differentiate any x, simply bring the original exponent down to the front to multiply it by the variable and then subtract 1 from the power. For the d per dx x power of n equals to nx power n minus 1. For the second one,
Next, we have the product rule. The product rule is a calculus shortcut is to find the derivative when two separate functions are multiplied together. By breaking the expression into two parts, the first function fx and the second function gx, we can find their derivatives separately, and then combine them by multiplying the first function by the derivative of the second and adding that to the second function multiplied with the derivative of the first.
for the third one is chain rule. The chain rule is used to find the derivative of a composite function, which is a function nested inside another function. In the rule, we need to use the equation separately and multiply the entire result by the derivative of the inner function g prime x. For the example is d per dx fx gx equals to f prime x gx plus fx g prime x. For the last one is quotient rule. The quotient rule is used to find the derivative when one function is divided by another, multiplying the bottom function lower by the derivative of the top function the height, subtract the top function height multiplied by the derivative of the bottom function below, and place that entire result over the original bottom function squared. For the example, for the quotient rule is d per dx fx per gx equals to gx f prime x minus fx g prime x per gx square. That's all. Thank you.
So we are going to do question number 2, which is find dy dx for the following function. We are going to do our first question, which is A. We have y equal to ln 2 plus x power of 3 secant 2 minus x. We're going to do step by step first. So our step 1, which is identify the method. This function is the product of two functions. So I use product rule. So we get u equal to ln 2 plus x power of 3 and v equal to secant 2 minus x. Moving on to step 2, we have to differentiate u. To differentiate the logarithmic function, I apply chain rule. So we get u prime equal to 1 over 2 plus x power of 3 multiplied with 3x squared. So we will get 3x squared over 2 plus x power of 3. We have to differentiate v. The derivative of secant is secant times tangent. Then I apply chain rule for the inner function, which is 2 minus x. We got v prime equal to secant 2 minus x tangent 2 minus x multiplied with negative 1. So we will get negative secant 2 minus x tangent 2 minus x. For step 4, we have to apply product rule formula. Now I substitute everything into the product rule formula. So we will get this. Moving on to our last step, which is step 5. We simplify everything here from this to this. So I factor out the common term, which is secant 2 minus x. So our final answer is this. We got secant 2 minus x, 3x squared over 2 plus x power of 3 minus ln 2 plus x power of 3 tangent 2 minus x. So right now we go to our next question, which is question B. For question B, we have y equal to e power of 3x squared over tangent x. So first step, we have to identify the method. So this function is in fraction form. So I use the quotient rule. So we get u equal to e 3x squared and v equal to tangent x. And then step 2, we have to differentiate u. To differentiate the exponential function, I use chain rule. So we get u prime equal to e power of 3x squared multiplied with 6x. And then step 3, we have to differentiate v, which is the derivative of tangent is secant square. And then moving on to step 4, we have to apply quotient rule. Now I substitute the derivative into the quotient rule formula. So we will get this. And then for step 5, we have to simplify all this. I factor out the common term, which is e3x squared. So our final answer is e power of 3x squared 6x tangent x minus 6 square x over tangent square x.
Right now, I'm going to answer question 3. Find dy dx using implicit differentiation. Given cos to the power of 4 bracket e to the power of 2y minus x to the power of 3 minus ln y to the power of 2 equals to 4xy. First, we need to differentiate each term. As you can see, I use the chain rule so that we break down the nested function from its outermost layer to the innermost layer to prevent algebraic mistakes, and then I'll multiply them. So when breaking down, I got 3a equals to 4 cos to the power of 3 bracket e to the power of 2e minus x to the power of 3. For 3b, I got negative sin to the bracket of e to the power of 2y minus x to the power of 3. And finally, we have 3c equals to 2e to the power of 2y dy dx minus 3x to the power of 2. Finally, by multiplying them all, we can get negative 4 cos to the power of 3 bracket e to the power of 2y minus x to the power of 3 sin bracket e to the power of 2y minus x to the power of 3 multiplied by 2e to the power of 2y dy dx minus 3x to the power of 2. Next, we'll differentiate negative 2 ln bracket y equals to negative 2 over x dy dx, and 4xy equals to 4y plus 4x dy dx. Combining it all, we can get negative 4 cos to the power of 3 bracket e to the power of 2y minus x to the power of 3 sine bracket e to the power of 2y minus x to the power of 3 bracket 2e to the power of 2y dy dx minus 3x to the power of 2 minus 2 over y dy dx equals to 4y plus 4x dy dx. Next, we put 4 cos to the power of 3 bracket e to the power of 2y minus x to the power of 3 sine bracket e to the power of 2y minus x to the power of 3 into negative a. Multiplying them, we can get negative 2e to the power of 2y minus a dy dx plus 3x to the power of 2 minus a minus 2 over y dy dx equals to 4y plus 4x dy dx. We group dy dx together and it becomes negative 2e to the power of 2y a dy dx minus 2 over y dy dx minus 4x dy dx equals to 4y plus 3x to the power of 2a. We then factorize become dy over dx bracket e 2e to the power of 2y a minus 2 over y minus 4x equals to 4y minus 3x to the power of 2a. By isolating dy dx, we can get 4y minus 3x to the power of 2a over negative 2e to the power of 2y a minus 2 over y minus 4x. Finally, by changing the a and simplifying it, we finally got 4y minus 12 x to the power of 2 cos to the power of 3 bracket e to the power of 2y minus x to the power of 3 sine bracket e to the power of 2y minus x to the power of 3 over negative 8e to the power of 2y cos to the power of 3 bracket e to the power of 2y minus x to the power of 3 sine bracket e to the power of 2y minus x to the power of 3 bracket minus 2 over y minus 4x.
Okay, so I will now be answering question 4. So for question 4, we need to use linear approximation to estimate the value of 16.03 square minus 1 over 4th root of 16.03 to correct the 3 decimal place. So now we need to define function and derivative, and to do that we need to take our values earlier and then substitute it into x. So let fx equal to x squared minus 1 over 4th root of x. Then we'll take the equivalence of 4th root of x into x power of 1 over 4. So to get the exponent form, we'll need to take the 1 over 4 and bring it to the top. Now we'll have the exponent form, which is x squared minus x to the power of negative 1 over 4. Differentiate the function using power rule. So the derivative of x squared is 2x. And for the exponent negative 1 over 4, we'll bring it to the other side, so it'll become a positive number, but then we'll also minus it by 1, so now we'll have 1 over 4x to the power of negative 5 over 4. This can also be rewritten as 1 over 4x to the power of 5 over 4, or 2x plus 1 over 4, 4th root of x to the power of 5. Now we need to choose value and delta x. Since our given value is 16.03, our chosen value will be 16, since 16 is closer to 16.03. So to find delta x, we'll do this our 16.03 minus 16, which will get 0.03. So to get linear approximation, we'll have to use the linear approximation formula, which is f of x0 plus delta x is approximately equal to f of x0 plus f prime of x0 times delta x. After that, we'll just take our given value and just plug it into the formula. So 16.03 square minus 1 over 4th 16.03 equals to f of 16 plus f prime of 16 multiplied by 0.03. So we'll take our function earlier and replace the x with our chosen value, which is 16. So it'll become 16 to the power of 2 minus 1 over 4th root of 16. And we'll need to add it to our f prime and replace the x in that with 16 too. So we'll get 2 multiplied by 16 plus 1 over 1/4 multiplied by 16 to the power of 5 over 4 and multiply everything by 0.03. So for our function, we'll get 256 minus 1/2, which equals to 511 over 2. And for our f prime, we'll get 32 plus 1 over 18, which equals to 257 over 8. And then we'll have to add those two numbers together and multiply it by 0.03, which we will then get the final answer of 256.460.
Calculus relies heavily on differentiation to measure the precise rate of change and identify the slope at any given point along the curve. By mastering systematic techniques like a power, product, quotient, and chain rules, complex mathematical problems become significantly more manageable. These analytical tools are vital across science, engineering, and business for tracking dynamic systems, while simultaneously fostering the critical thinking skills necessary for advanced academic her sheets.